Hello and welcome to the last section of the video version of the notes for Unit 10. Alright, so this section we're going to be talking all about the zero product property. And then we're going to do a little bit of review with factoring and graphing later on. But to start, the zero product property says that if I multiply, I'm just going to pick some random numbers. If I multiply any number times 0, it's going to equal 0. If I multiply 0 times any number, it's going to equal 0. So anytime I multiply anything times 0, it equals 0, or 0 times anything, it always equals 0. So I know this is basic knowledge that we should all know, but this is kind of what the zero product property is telling us. So if I move on to example 1, I'm multiplying x minus 7 times x plus 2. So if I want that to equal 0, if I make this equal 0, 0 times x plus 2 will be 0, because it doesn't matter what x plus 2 is. I'm multiplying it times 0, so it's going to be 0. Or if I make x plus 2 equal to 0, then this whole thing is going to equal 0, because 0 times whatever x minus 7 is going to be, it's always going to be 0. So basically what we have to do is we have to figure out what can x equal to make x minus 7 equal to 0. And then what can x equal to make x plus 2 equal to 0. So I'm taking the two factors here that I have, setting them equal to 0. So if I add 7 to both sides, I get x equals 7. If I subtract 2, I get x equals negative 2. And those, in fact, are your two answers. So x equals 7, or x equals negative 2. So again, just like in previous sections, we have two answers because we have two x-intercepts. If I graph this, so there would be two x-intercepts or two roots. So that's why there's two answers. So again, I'm going to do the same thing. So I start with the first factor, set it equal to 0. Second factor, set it equal to 0. So I don't have to do anything with this. X just equals 0. I just subtract 4 on both sides here, so x equals negative 4. So my two answers are going to be x equals 0 and x equals negative 4. So again, zero product property says that if one of the factors, if you're multiplying two things, if one of those things is 0, no matter what the other one is, your answer is going to be 0, which is what we always want because these are 0. So in the next example, again, we have two factors, but it gets a little bit more complicated. So I got 2x plus 3. I'm going to set that equal to 0. And then x minus 3, I'm going to set that equal to 0. So this one's easy. I just add 3 to both sides and I get x equals 3. This one I got to do a little bit of math. So if I subtract 3 on both sides, I get 2x equals negative 3. If I divide both sides by 2, I get x equals negative 3 over 2. So our two answers would be x equals 3 and x equals negative 3 halves. Then I'm going to do the same thing here. So again, I just want one of these to be 0 to make this whole thing equal 0. So 2y plus 3. If that equals 0, then I'm good. Or if y plus 13 is equal to 0, then I'm good. So this one's easy. Just subtract 13 on both sides and you get y equals negative 13. This one I'm going to subtract 3 and get 2y equals negative 3. Then divide by 2 and I get y equals negative 3 over 2. So again, I get an answer of y equals negative 3 halves. Then my other answer this time is y equals negative 13. So that's kind of how the zero product property works. We just set each of the factors equal to 0. So then example 3, it gets a little bit more involved here. This time I got to solve the quadratic equation by factoring. So this is a good review. So you don't have to use the box, but I like to use the box here to factor. So A is 1, C is 8, and then B is negative 6. So two numbers that multiplied equal 1 are 1 and 1. Then I need two numbers that multiplied equal positive 8, but when you add them together equal negative 6. So if they add up to a negative number but multiply to a positive number, they both have to be negative. So I'll try negative 4, negative 2. So when I multiply across, I get 1 times -4 is -4, 1 times -2 is -2. So these two numbers, when I add them together, do equal -6. So that means my factors are in here. So 1 times x, or x minus 2 times x times 1, or x minus 4. And it still equals 0. So now I can apply the zero product property. So I want x minus 2 to equal 0, and x minus 4 to equal 0. So that means x will equal 2 and x will equal 4. So those are our two roots. And then the second part of example 3. So again, I'm going to have to factor. So I'll start off my little factor box here. A is 1, C is 36, B is -12. So this has to be 1 and 1 because those are only two numbers, two whole numbers that'll multiply together to equal 1. So then I need two numbers that multiply to equal 36 that also add up to -12. So if they have to add up to a negative number and multiply to a positive number, they have to both be negative. So let's see, what if you're not sure, like I can't think of it off the top of my head, so I'm gonna make a factor tree. So 36, start with 1 and 36. It's an even number, so I know 2 goes into it. So 2 and 18. 3 goes into 36 12 times. 4 goes into 36 9 times. And then 6 and 6. So those are all the factors of 36. So if I added any of these two together, do any of them equal 12? Oh, 6 and 6. But it's -12, so they have to be -6 and -6. So I have 1 times x minus 6. So x minus 6, x minus 6 equals 0. So x minus 6, and by the way, another way to write that is x minus 6 squared equals 0. So I want x minus 6 to be 0 and then x minus 6 to be 0. But we're going to get the same thing, so x equals 6, x equals 6. So this time I only have one answer. X equals 6. Because this is saying the same thing, so I don't write it twice. The reason I wanted to show you x minus 6 squared is because whenever you have a perfect square, so in this case x minus 6 squared equals 0, you're only going to have one answer. This means the vertex is an x-intercept or root. So that's why you only get one answer. And I know you guys don't have this little space on your notes, so I'm sorry for writing over there. But I'm sure you can figure out a spot to put that. All right, so on the next page, we're going to have to factor again. So first thing I will need to do is get one side equal to 0. So 2x squared plus 29x. If I add 14 to both sides, that becomes 0. So now I'm going to try to factor all of this. So a is 2, c is 14, and b is 29. So we're all positive, so that means all positive numbers will be inside of here. This has to be 2 and 1, or you can do 1 and 2. So factors of 14 are either 7 and 2 or 14 and 1. But I know right away if I do 2 times 7, that's 14. 1 times 2 is 2. That's not going to add up to 29. So I know it has to be 14 and 1. So 2 times 14 is 28. 1 times 1 is 1. So 28 plus 1 is 29. So that means my numbers are good. So the factors are inside of here. So 2x plus 1 times 1x minus, or 1x plus 14, or x plus 14. So now that I have the two factors, I can use the zero product property and set each factor equal to 0. So 2x plus 1 equals 0, and x plus 14 equals 0. So this one's easy, just subtract 14 on both sides and you get x equals -14. This one you got to subtract 1 on both sides and get 2x equals -1 divided by 2, and x equals -1 over 2. if I'm going too fast at any point, make sure you are pausing the video because I know I'm going kind of fast over some of these parts. All right, so example 5, I got to solve the quadratic equation by factoring. So first thing I'm going to do is I'm going to set one side equal to 0. I'm just going to add 2x squared to both sides because that'll be quicker. So now I have 0 equals 2x squared plus 20x plus 50. So one thing that I have not mentioned that you should always do when you're factoring. First thing you should always check for is, do all of these numbers have a common factor? And if they do, we want to factor or divide by that number. So they are all even, so that means I can factor out a 2 or divide by 2 in this case. So if I divide both sides by 2, actually let's do this. So when I divide the right side, I have to divide all of the numbers that are separated by a plus sign by 2. 0 divided by 2 is 0. 2 divided by 2 is 1, so x squared. 20 divided by 2 is 10, so plus 10x plus 25. So now, you don't have to do that, but it's going to be a lot easier to factor this if you divide out or factor out all the common factors. So A is 1, C is 25, and B is 10. I'm going to have all positive numbers. I know that these two have to be 1 because 1 times 1 is 1. Two numbers that multiply together to equal 25. It's either 25 and 1 or 5 and 5. I'm going to guess it's 5 and 5. So 1 times 5 is 5. 1 times 5 is 5. So I have x plus 5 times x plus 5 equals 0. So another way to write this is x plus 5 squared equals 0. So whenever we have a perfect square, that means we're only going to have one answer. So our answer will be x equals negative 5. So some graphing now. So you gotta, in order to graph this, you have to remember what form this is in, what you have to do. This is not descriptive form or vertex form. So it's not going to be easy to find the vertex. So it's in standard form. So hopefully you remember that little formula you have to use when it's in standard form to find the vertex. So x equals negative b divided by 2a. So don't forget this thing. You have to remember it. So b is 6. So I'm going to have x equals negative 6 divided by 2 times a. A is 1. So negative, oops, I just wrote the answer. Negative 6 divided by 2 is negative 3. So our line of symmetry, let me write this somewhere else so I don't block the graph. X equals negative 3. Now I need to find the vertex because that's where I'm going to start the graph. So the vertex is going to be negative 3, comma something. So to figure out the y value, I plug in negative 3. So y equals negative 3 squared plus 6 times negative 3 plus 8. Negative 3 times negative 3 is 9. 6 times negative 3 is negative 18. And then plus 8. So when I add all these together, 9 minus 18 is negative 9 plus 8 is negative 1. So negative 3, negative 1 will be the vertex. So I go left 3, down 1 to get to the vertex. I'm going to use that little pattern. So 1, 3, 5, 7, dot, 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 dot. Our a value is 1, so that means I multiply all these by 1, which means they stay the same. So I'm going to go up 1, right 1. Same to the left. Then I go up 3, 1, 2, 3, right 1. Same to the left. And you could do it again, but that's good enough. Oops. So there's our little graph. The axis of symmetry I already wrote as x equals -3, but that would be right here. It's right down the center of the vertex. And then our last problem in this section. So again, I got to do -b divided by 2a. b is -5, so I'm going to have -5 divided by 2 times a, which is 1. So negative turns into a positive, so 5 divided by 2. Oops, we'll just leave it like that. If you want to put 2.5, you can, but that's fine. So this is our line of symmetry. So now I'm going to graph this, but before I do that, I have to find the vertex. So I know the x value is 5/2. You know, on second thought, I'm just going to skip this one because I don't want to deal with fractions, and we've gone over time, so don't worry about this one.